Welcome to your quiet corner of cosmic discovery. I'm here to share something genuinely fascinating about our universe at just the right volume for drifting off. You know what's fascinating? How we measure the vastness of space with something called a light year. I've been thinking about it lately, not just as a number or a distance, but as a little story about how light travels through the quiet darkness between stars. It's a gentle reminder of how connected we are to the universe, even across unimaginable distances, and I can't wait to share that with you tonight. Should you find solace in these cosmic lullabies, consider becoming a regular dreamer by subscribing. Share what topics intrigue your curious mind in the comments below. Take this moment to settle in, wrap yourself in comfort, release the day's weight from your shoulders, and let your breath become as gentle as starlight. There is a certain magic to the phrase light year. It arrives on the tongue with the taste of distance and wonder, its syllables stretching out like a ribbon of midnight sky. For many, it conjures visions of sleek starships arcing between galaxies, of cosmic odysseys played out against a backdrop of twinkling constellations. The words seem to pulse with the promise of the impossible, as though one could simply step into the slipstream of light and emerge elsewhere, far, far away, carried on the wings of speed itself. Yet, in the hush before sleep, as the world dims and the mind reaches for stories to carry it into dreams, the true nature of a light year often slips through our fingers. It is a measure both precise and mythic, a creation of the scientific imagination, yet woven deeply into the fabric of our cultural storytelling. Tonight, we linger at the threshold of understanding, exploring not the cold arithmetic of light's passage, but the ways in which the idea of a light year has shaped our culture, our fiction, and the secret maps of distance that reside in every curious heart. The phrase itself is a relatively recent arrival in the lexicon of human thought. For most of our history, the sky was a dome close at hand, the stars pricked into its surface like lanterns in the ceiling of a great hall. The ancients measured the heavens in spans of outstretched arms, in the crawl of the sun across the horizon, in the slow ballet of the moon around the earth. It was not until the last few centuries, with the coming of telescopes and mathematics, that we began to grasp the true enormity of the cosmos. Suddenly, the distances between the stars stretched beyond all reckoning. Miles and even kilometers proved laughably inadequate. A new metric was needed, one that could scale the chasms between suns. Enter the light year, the distance that light, racing at its incomprehensible velocity, covers in a single year. It is a number so large, nearly 10 trillion kilometers, that it resists easy imagination. And so, paradoxically, the light year became not only a scientific yardstick, but a vessel for awe, a symbol of the unreachable, the sublime. It is both a measure and a metaphor, straddling the worlds of fact and fantasy. In the silver-lit halls of fiction, the light year quickly found a home. Science fiction, that great engine of imaginative speculation, seized upon the term and spun it into the warp and weft of its narrative fabric. From the earliest pulp magazines to sprawling modern epics, the light year became shorthand for the grandeur of space, the dizzying vastness that separates worlds. Writers used it to lend authenticity to their star-faring tales and to evoke the existential vertigo of cosmic travel. When Han Solo boasts of the Millennium Falcon making the Kessel Run in less than 12 parsecs, or when Captain Kirk orders warp speed to a distant star system, the language of light years hums in the background, an invisible thread connecting our earthbound lives to the farthest reaches of the universe. Yet, even as it evokes the infinite, the light year is often misunderstood. It is, after all, a measure of distance, not time, a subtlety that slips easily past the casual listener. In popular conversation, the phrase "light years ahead" is commonly used to suggest a leap forward in time, as if the future itself could be measured in the same units as interstellar space. Advertisers claim their products are light years ahead of the competition, and commentators describe technological leaps as light years into the future. The confusion is understandable. The word year carries a temporal weight, and the speed of light is so intimately tied to ideas of time and causality that the distinction blurs. This blending of distance and duration is not merely a linguistic slip. It is a testament to the human mind's struggle to comprehend the scale of the universe. Our everyday experience is bounded by the immediate and the tangible, the length of a road, the span of a lifetime, the distance to a neighboring town. When confronted with the distances between stars, our metaphors strain and buckle. The light year, with its dual hints of time and space, becomes a bridge, a way of gesturing toward the almost unimaginable without succumbing completely to abstraction. The allure of the light year is amplified by the stories we tell about the stars. For generations, the night sky has been a canvas for our hopes and fears. Myths were painted in constellations, gods and monsters striding across the firmament. In the age of science fiction, the stars became destinations, and the spaces between them challenges to be overcome. The light year, in this context, is both obstacle and invitation. It is the measure of the hero's journey, the gulf that must be crossed to reach new worlds, the symbol of isolation and the promise of encounter. Consider for a moment the great space operas that have defined modern culture. In Isaac Asimov's Foundation series, the distances between planets are measured in light years, the empire sprawled across the galaxy like a colossus. The very scale of the setting is made tangible through the invocation of the light year, grounding the reader in the reality of a universe where travel and communication are acts of both technological prowess and narrative daring. In Arthur C. Clarke's Rendezvous with Rama, the approach of an alien starship from the depths of interstellar space is rendered all the more mysterious by the light years it has traversed, its origins shrouded by the sheer magnitude of distance. Television and film, too, have harnessed the evocative power of the light year. In Star Trek, the Enterprise glides serenely from one star system to another, distances measured in light years flickering across the navigation charts. The very phrase warp speed is an homage to the tyranny of distance, a promise that even the vastness of space can be bent to human will. The light year becomes a unit, not merely of measurement, but of narrative tension, a way of quantifying the stakes, the peril, and the triumph of each voyage. Yet, as these stories proliferate, so too do misconceptions. The notion that a light year measures time is perhaps the most persistent, but it is far from the only confusion. Some imagine that traveling 1 light year requires a year of journey, regardless of speed. Others picture the light year as a kind of chronological milestone, a marker of how long ago an event occurred. In truth, the light year is stubbornly literal. It is the distance light travels in a year, no more and no less. The confusion arises, in part, because of the interplay between the speed of light and the structure of the universe, a dance that is, in itself, a source of wonder. There is a peculiar irony in the way the light year both clarifies and obscures our understanding. It brings the cosmos within reach, translating the incomprehensible into terms we can at least attempt to grasp. At the same time, it reveals the limits of our intuition, the ways in which our minds are shaped by the scale of our daily lives. The light year is a window onto the vastness of the universe, but it is also a mirror, reflecting our own longing to comprehend, to measure, to name. Artists and poets, too, have found in the light year a potent symbol. It is a way of expressing longing, of capturing the ache of distance and the hope of reunion. Lovers separated by light years evoke not only space, but time, the slow drift of memory and desire. In music, the phrase shimmers with melancholy and anticipation, a reminder that some distances cannot be crossed by mere footsteps or words. The light year becomes a metaphor for all that is remote, all that is desired and unattainable. Even in the realm of the everyday, the light year has seeped into our language, colouring our perceptions of progress and change. To be light years ahead is not simply to be advanced, but to surpass the ordinary by an almost cosmic margin. The phrase lends a kind of grandeur to otherwise mundane achievements, a sense that the horizon has been pushed back and the future drawn closer. Yet, for all its ubiquity, the light year remains, at heart, a scientific construct, a product of careful measurement and theoretical insight. Its presence in our culture is a testament to the power of science to reshape not only our understanding of the universe, but also the stories we tell about ourselves. The light year is a bridge between worlds, linking the cold precision of physics to the heat of human imagination. There is something deeply human in this act of translation, this urge to take the abstract and make it meaningful. We reach for metaphors because they allow us to grasp what is otherwise ungraspable. The light year, in this sense, is not merely a unit of distance, but a vessel for wonder, a way of holding the universe in the palm of the mind. The cultural resonance of the light year extends even to our sense of history. When we gaze at the stars, we are seeing into the past. The light from distant suns began its journey long before we were born. To say that a star is 10 light years away is to say that we see it as it was a decade ago, its present hidden from us by the finite speed at which light travels. This intertwining of distance and time, of presence and absence, lends a certain poignancy to our stargazing. We are always looking backward, peering through the layers of cosmic history, our own existence woven into the tapestry of light. In classrooms and planetariums, educators wrestle with the challenge of conveying the true scale of the universe. How to make sense of a distance so vast that it defies analogy? Some compare a light year to the circumference of the Earth, multiplied by a staggering number. Others describe it in terms of journeys to the moon, or the time it would take to circumnavigate the globe at supersonic speeds. Yet every analogy falters, every comparison falls short. The light year remains, ultimately, an act of faith, a belief that the universe can be measured, that its vastness can be named. As the night deepens and the mind drifts toward sleep, the phrase light year lingers in the air, heavy with meaning and mystery. It is a reminder of all that lies beyond our reach, and of the power of language to bridge the gap between knowledge and wonder. The next time you hear the term, whether in a book, a film, or a casual conversation, pause for a moment and let its full weight settle over you. Consider the centuries of yearning and imagination that have given it shape, the storytellers and scientists alike who have reached for the stars, seeking to measure the unmeasurable. We stand on the shore of an ocean without end, casting words like pebbles into its depths, hoping to hear an echo from the far side. The light year is one such word, a stone flung into the darkness, a measure not only of distance, but of dreaming. And so, as our journey continues, we turn from the stories we tell about the light year to its reality, the science behind its measure, the speed of light itself, and the ways in which this simple unit reshapes our understanding of space and time. The adventure lies not only in the distances themselves, but in the very fabric of light, and in the quiet, relentless motion by which the universe reveals its secrets. Picture, if you will, the silent vastness between stars. It's a darkness not of emptiness, but of untold depth, a realm where familiar measures unravel and distances mock our everyday intuition. Somewhere within that blackness, a beam of light is born, uncoiling itself from the furious heart of a star. It leaps outward, traversing gulfs so immense that our accustomed tools, meters, kilometers, even planetary orbits, are rendered laughably inadequate. To speak of such distances, science needed a new unit, one born from the very speed of light itself. Thus, the light year was conceived, a phrase that, at first blush, seems almost poetic, yet is laced with profound meaning and subtlety. The light year, it is not a measure of time, though the name might beguile. Instead, it is a measure of distance, defined by the span that a single photon, a quantum of light, travels through the vacuum of space in the course of one Earth year. This is no arbitrary figure, but a physical constant rooted in the very structure of the universe. In each tick of a clock, light races along at approximately 299,792 kilometers per second, over 186,000 miles per second. Multiply this blistering velocity by the number of seconds that make up a year, 31,557,600 if you count every second of every day, and you arrive at a staggering sum, roughly 9.46 trillion kilometers, or nearly 5.88 trillion miles. Yet, to dwell on the arithmetic is to miss the deeper essence. The light year is not merely a number, it is a bridge between the scales of the cosmos and the limitations of the human mind. It is a way to render the incomprehensible, those yawning stretches between stars and galaxies, into something our minds can, if not fully grasp, at least gesture towards. When astronomers tell us that Proxima Centauri, the nearest star beyond our own sun, resides 4.24 light-years away, they are not simply reciting a fact. They are inviting us to reckon with a journey that, at light's tireless pace, takes over 4 years to complete, one that would demand tens of thousands of human lifetimes in even our fastest spacecraft. But the light year, for all its elegance, is a construct built upon assumptions drawn from the very fabric of spacetime. To understand it, one must first peer into the nature of light itself, and the strange stage upon which it performs its endless dance. Light, according to our best understanding, is more than just the visible radiance we find in a sunbeam or the glow of a lamp. It is an electromagnetic wave, a trembling in the fields that pervade space, and paradoxically also a particle, a photon, that carries discrete packets of energy. It travels not through some invisible medium, as once imagined, but through the vacuum itself, heedless of wind or ether. Why does light move at this particular speed? The answer is etched into the equations of James Clerk Maxwell, whose 19th century insight revealed that the speed of light arises from two fundamental properties of the vacuum, its electric permittivity and magnetic permeability. These constants define how electric and magnetic fields influence each other, and their interplay sets an upper speed limit for any disturbance, light included. Thus the speed of light is not a local peculiarity, but a universal decree. It is the same in all directions, for all observers, regardless of their own motion. This invariance, so counterintuitive, forms the bedrock of Einstein's theory of relativity, a theory that would forever alter our conception of space and time. It is here, in the interplay between relativity and the light year, that complexity blooms. In the Newtonian world, distances were absolute, and time ticked evenly across the cosmos, like a great celestial metronome. But relativity teaches us otherwise. Space and time are not separate threads, but interwoven, forming a fabric whose shape is bent and stretched by matter, energy, and motion. If you move fast enough, the distances you measure contract. The passage of time itself warps. Light, however, is the great exception. Its speed is the same for all, even as all else seems to shift and twist. So, when we say a star is 10 light-years away, what do we truly mean? Are we measuring along a ruler laid flat across an unchanging void? Or are we tracing a path through a dynamic, contorted space-time, one that expands and curves as the universe itself grows? In truth, the answer leans toward the latter. The cosmos is not static. It swells outward, its fabric stretching, driven by forces we only partially comprehend. Distances between galaxies and even between some stars are not fixed but grow over time. The light year, so impressively precise in local terms, becomes slippery when stretched across the larger scales. Consider this. The light from a galaxy 1 billion light-years away did not, strictly speaking, travel 1 billion light-years in the sense of a fixed, unchanging stretch of space. While that light journeyed toward us, the space between our galaxy and its origin was itself expanding, pulled by the cosmic tide. In the language of cosmology, there are multiple ways to define distance. The light travel distance, marking how far light has moved, the comoving distance, which accounts for expansion, and the proper distance, which can change as the universe evolves. The light year, then, is a useful shorthand, but it quietly elides the subtleties of a restless, evolving cosmos. Even nearer to home, the light year is bound to the constancy of the second, and by extension to the rotation of our own small planet, a planet whose motion is itself not perfectly uniform over eons. The second, once tied to the swing of pendulums and the cycles of celestial bodies, is now defined by the quantum vibrations within atoms. The light year, though seemingly cosmic in scope, is tethered to the rhythm of terrestrial clocks and to our place within the universe's machinery. Peering deeper, there is another subtlety to consider. The very speed of light, which forms the backbone of the light year, is not merely a fast pace, but the ultimate speed limit for any information or influence in the universe. Nothing material, no ship, no signal, may ever surpass it. This is not a matter of technological limitation, but of physical law. To accelerate any object with mass to the speed of light would demand infinite energy, a demand the universe simply does not permit. Hence, the light year is not only a measure of distance, but of the possible, of the horizons that lie forever out of reach for any traveller bound by matter. And yet, for all its limitations, the light year is a tool of discovery. Through it we peer into the past, for every gleam of starlight that reaches our eyes is an ancient messenger, bearing witness to a moment long vanished. When you gaze at a star 10 light-years away, you are seeing it as it was 10 years ago, its current state forever hidden until the next wavefront arrives. For the great galaxies, the delay stretches into the millions and billions of years. To look out into space is to look back in time, the light year tracing a corridor through both space and history. But the universe is not content to offer us a clear window. Between the stars and our telescopes lies the interstellar medium, a sparse fog of gas and dust which dims and reddens the light as it travels. Some wavelengths slip through unscathed, while others are absorbed or scattered, their message muddied by the journey. The true distance a photon traverses is not always a straight line. It may be slowed, diverted, or even swallowed entirely before reaching us. The light year, in its clean definition, does not account for these impediments. Another reminder that our measurements are ever approximations, mere echoes of the underlying reality. There are, too, the peculiar tricks played by gravity. Massive bodies, stars, planets, even dark matter, warp the space-time around them, bending the trajectories of passing photons. A beam of light passing near a massive star may curve, its path elongated and its arrival delayed. This effect, known as gravitational lensing, can even produce multiple images of the same distant object arriving at different times. The light year, in practice, must be measured along these twisted paths, tracing the true journey rather than the straight-line distance. And what of the limits of our perception? Our instruments, however exquisite, are bound by the sensitivity of their detectors and the clarity of our atmosphere. There are cosmic horizons beyond which light has not yet reached us, or never will, a boundary set not by distance alone, but by the age and expansion of the universe itself. The observable universe, defined by the furthest light that has had time to arrive since the Big Bang, is a sphere some 46 billion light-years in radius, not because those places are so far away now, but because of the complex interplay between time expansion and the speed of light itself. These complexities reveal the light year as both a triumph and a compromise, a symbol of our ingenuity and a testament to the universe's refusal to be easily tamed. It is a unit that floats between absolutes and approximations, between the certainty of mathematics and the shifting stage of cosmic history. When we speak of light years, we are not merely counting kilometers, but invoking a conversation across epochs between the laws of physics and the restless march of time. There is a deep poetry to this, for the universe, in its enormity, offers no easy answers, only questions that unfold into deeper mysteries. The light year, for all its precision, is a measure shadowed by uncertainty. It is shaped by the expansion of space-time, the warping of gravity, the interference of dust and gas, and the limits of our own instruments and understanding. It is, in the end, a human attempt to make sense of the cosmos, a yardstick laid across the infinite, ever subject to revision as our knowledge grows. And so, as we ponder the meaning of a light year, we find ourselves drawn into the very heart of scientific inquiry. We are reminded that every measurement is both a window and a veil. It reveals, but it also obscures. The numbers we recite are not final truths, but stepping stones, markers on a journey that winds ever outward, towards the edge of what can be known. In the silence between stars, where light travels on and on, the questions only deepen. What lies beyond the reach of our longest measures? Are there forms of distance, of connection, that elude even the fleetest photon? As we drift further into the night, the fabric of space-time stretches before us, unfolding, beckoning, inviting us to ask what it means to traverse the universe and what new wonders might await just beyond the horizon of the next light year. It is a peculiar thing to measure the unmeasurable, to take the sheer, gaping scale of the cosmos and attempt to pin it down, to assign numbers, to make a yardstick of light across the black velvet of space. For most of human history, the distances between the stars seem not only unfathomable, but fundamentally beyond reach. An ocean without horizon, a gulf so wide that even the possibility of crossing it or marking it belonged to gods and poets, not to mortals. Yet with patience, with ingenuity, and with a kind of stubborn reverence, people found ways to coax numbers from the darkness. The story of how we came to measure space in light years is not just a tale of mathematics and machinery. It is a chronicle of questions stretching across centuries, of minds reaching for the farthest things they could imagine and refusing to accept that those things must remain forever unknown. To begin, we must first remind ourselves what a light year is, the distance that light, travelling at its constant and staggering speed, about 299,792 kilometers per second, can cover in a single year. That is roughly 9.46 trillion kilometers, or nearly 5.8 trillion miles. Such a number slips through the fingers of the mind. It is too large to hold. And yet, it is the foundation on which our understanding of the universe is built, a ruler made not of wood or metal, but of light itself, the fastest thing we know. But how did we come to know such things? How, in the first place, did anyone measure the speed of light, let alone the distances it could span across years? Consider, for a moment, the world before telescopes, before even the faintest glimmer of scientific astronomy. The ancients peered up at the stars, mapping their wanderings, charting their patterns, but always the sky was a dome, a canvas, its depth unknowable. The stars themselves seemed like lanterns set into a great ceiling, their distance irrelevant. The idea that they might be suns, scattered across infinite reaches, was a notion that would have seemed both blasphemous and absurd. It was not until the Renaissance, that great flowering of curiosity and skepticism, that the first seeds of measurement were sown. Galileo Galilei, peering through his crude telescope in the early 17th century, saw that the stars were not just points, but multitudes, stretching in every direction. Yet even he, with his revolutionary vision, could not measure their distance. The stars refused to resolve. They remained, maddeningly, always just out of reach. To measure a distance, one must have a scale, a reference, a way to triangulate. On Earth, this is simple enough. A surveyor plants 2 stakes, measures the angle between them and a distant object, and uses trigonometry to calculate the distance. But the stars are so far away that from one side of the Earth to the other, their positions in the sky hardly shift at all. The ancient Greeks, notably Hipparchus and later Ptolemy, tried to use this method, parallax as it is called from the Greek word for alteration, but succeeded only in proving that the stars were far, far more distant than anyone had guessed. The parallax angle was, for them, too small to detect. The stars might as well have been painted on the inside of a great sphere. Yet the idea of parallax lingered, waiting for better tools. The real breakthrough came not from geometry, but from time. In the late 17th century, Danish astronomer Ole Rømer made a discovery that would forever change our sense of the cosmos. He was studying the eclipses of Jupiter's innermost moon, Io. He noticed that when Earth was moving away from Jupiter, Io's eclipses appeared to occur later than predicted. When Earth moved closer, the eclipses came sooner. By carefully recording these differences, Rømer deduced that light must take time to travel, that its speed was finite. He estimated the speed of light at about 220,000 kilometers per second, less than the true value, but a revelation nonetheless. The spark had been struck. Light was not instantaneous. It had a speed, and therefore a measurable distance. Once the speed of light was known, even approximately, the next step was to use it as a cosmic measuring tape. But first, astronomers had to refine their techniques for measuring distance, for finding the true scale of the heavens. Parallax, the ancient method, returned to center stage, but now with vastly improved instruments. In the early 19th century, German astronomer Friedrich Bessel turned his telescope to the star 61 Cygni, a modest, faint double in the constellation Cygnus. Using a device called a heliometer, designed to split and compare images with extraordinary precision, Bessel measured the tiny wobble of the star's position as Earth swung from one side of its orbit to the other. A shift so slight it was less than a single second of arc, or about the width of a penny, seen from 3 miles away. From this, he calculated that 61 Cygni lay about 3 light-years from Earth, a distance so vast it staggered the imagination. For the first time, a star had been pinned to a map. The universe had depth. The technique of parallax remains, to this day, the gold standard for direct distance measurements in astronomy, at least for relatively nearby stars. It relies on the simple principle of triangulation, but on a cosmic scale. As Earth moves through its orbit, observers measure the apparent shift in a star's position against the far more distant background. The larger the parallax angle, the closer the star. With modern instruments, space telescopes like Hipparchus and Gaia above the blurring effects of our own atmosphere, astronomers can measure parallax angles for stars thousands of light-years away with a precision undreamed of by Bessel and his contemporaries. But as the distances grow, the angles shrink until even the most sensitive detectors can see no further. For the vast majority of stars and galaxies, parallax becomes impossible. the universe stubbornly slips beyond the reach of our most elegant ruler. And so, astronomers have devised new tools, new methods, each more ingenious than the last. There is, for example, the method of standard candles. Some stars, by their very nature, shine with a well-known, predictable brightness. If you know how bright something truly is, and you can measure how bright it appears, you can calculate its distance. The farther away it is, the dimmer it looks, following the simple laws of geometry. The first standard candles were Cepheid variables, stars that pulse in a regular rhythm, their period of pulsation linked to their intrinsic luminosity. Henrietta Swan Leavitt, working at Harvard in the early 20th century, catalogued thousands of these pulsating stars in the small Magellanic Cloud, a neighboring galaxy. She discovered that the longer the period of pulsation, the brighter the star. This Leavitt law became a cosmic yardstick. By finding Cepheid variables in distant galaxies, astronomers could measure distances far beyond what parallax could reach, out to millions of light-years. Later, other standard candles were found, the brilliant explosions of type Ia supernovae, for instance, which blaze with such uniform intensity that they can be seen across billions of light-years. With these tools, astronomers mapped the universe out to unimaginable distances, layer upon layer, each method building upon the last, a cosmic ladder stretching into the void. Alongside these indirect methods, the very tools of observation, the telescopes themselves, have evolved in ways that would astound their earliest inventors. The first telescopes were little more than tubes of glass and wood, their lenses ground by hand. But as the centuries unfolded, the instruments grew in power and precision. The great refractors and reflectors of the 19th and 20th centuries, perched atop remote mountaintops, gave way in turn to radio telescopes, catching whispers from the universe at wavelengths invisible to the eye. The Hubble Space Telescope, launched above the atmosphere, saw further and more clearly than any ground-based instrument, revealing galaxies in their infancy, scattered across the primordial darkness. But measurement is not merely the domain of the telescope. It is also the art of calibration, of cross-checking, of building a web of interlocking techniques. Take, for instance, the method of redshift. As light travels across the expanding universe, its wavelength is stretched, shifted toward the red end of the spectrum. The more distant a galaxy, the faster it appears to be receding, and the greater its redshift. By measuring this shift and knowing the rate of cosmic expansion, the Hubble constant, astronomers can estimate the distance to remote galaxies, billions of light-years away. This method, too, relies on painstaking calibration, using standard candles and parallax as stepping stones, each link in the chain checked and rechecked, lest a single error ripple outward and distort the entire map. Of course, each of these techniques comes with its own uncertainties, its own sources of error and ambiguity. The universe is not a laboratory. It does not yield its secrets easily. Dust dims the light of distant stars, making them appear farther than they are. The true brightness of a supernova may vary ever so slightly with the composition of its host galaxy. Even the speed of light, once thought to be an unchanging constant, has been measured and remeasured with ever greater precision as new experiments refine our understanding. Consider the tools themselves, the photometers that measure the faintest glimmers, the spectroscopes that split starlight into its constituent colors, the gyroscopes and star trackers that keep telescopes precisely aimed at their targets for hours, even days. On Earth, observatories perch atop volcanoes and deserts, searching for the clearest, driest air. In space, satellites drift in silent orbits, their instruments cooled to near absolute zero, shielded from the warmth and chaos of our planet. Each device is a marvel of engineering, a monument to the patient collaboration of thousands of minds, each working toward the same impossible goal, to measure the incomprehensible. There is beauty, too, in the experiments themselves. The Michelson-Morley experiment, in the late 19th century, sought to measure the speed of light with unprecedented accuracy, and in doing so helped lay the groundwork for Einstein's theory of relativity. Later, lasers and atomic clocks refined these measurements still further, making the speed of light not just a measured value, but a defined constant, the ultimate ruler against which all others are compared. And yet, for all our tools, our cleverness, our centuries of labor, the universe remains profoundly vast, profoundly mysterious. Each new measurement, each new technique opens doors to still greater questions. The light year, that elegant unit born from the marriage of time and speed, is both a triumph and a confession, a triumph of human ingenuity, a confession of our limitations. We can measure, we can map, we can reach out across the void with numbers and equations, but always the darkness stretches further, the unknown beckons. Still, the work continues. Even now, astronomers plot the distances to ever more remote galaxies, searching for the faintest signals, the subtlest shifts in starlight. New missions are planned, satellites and telescopes that will probe deeper, measure more precisely, extend the cosmic ruler still further into the night. With each new tool, each new experiment, we come a little closer to understanding the true scale of the universe. And yet, for all our progress, there is always another horizon, another question, another glimmer in the dark, waiting to be measured. So our journey through the cosmos, through the language of light years, is not merely a matter of numbers and instruments. It is a story of yearning, of reaching, of refusing to accept the limits of sight or imagination. It is a testament to the power of curiosity and to the quiet, persistent hope that, with patience and ingenuity, we might one day know our place among the stars. Yet, even as we measure and map, another mystery arises, one not of distances, but of time. For light, as it travels, carries not only the news of distance, but the memory of ages past. The further we look, the older the light we see. Thus, measuring in light years is to look, always, into history, to see not just how far, but how long ago. The tools that capture these ancient signals are also, in their way, time machines. And so, as we peer ever deeper, ever further, we find ourselves drawn not only across space, but backward through the ages, toward the origins of stars, galaxies, and perhaps to the birth of the universe itself. There is a peculiar comfort in the darkness of a quiet room, when all is still save for the faint ticking of a clock or the soft hush of one's own breath. At such moments, thoughts seem to expand, brushing gently against the boundaries of the self, reaching outward into the night. The mind, like a silent traveller, drifts to distant places, wandering among questions too vast for the daylight hours. In this hush, the idea of a light year itself becomes less a sterile unit of measurement and more a vessel, capable of carrying us beyond our terrestrial concerns, into the profound poetry of existence. The light year, on its surface, is a simple thing. The distance that a beam of light, moving through the cold vacuum of space, will traverse in the span of a single Earth year. Nearly 9.46 trillion kilometers, or about 5.88 trillion miles, numbers so large they seem to defy the imagination. Yet these numbers are not merely cold facts. They are the language with which we whisper to the stars, a bridge between our world and the unfathomable distances that cradle the universe. To speak of light years is to speak of time as much as space. When you gaze upon the bright blue-white jewel of Sirius in the winter sky, you are not seeing it as it is, but as it was more than 8 years ago. That starlight began its journey long before you blinked your first waking thought this morning. It left Sirius before the present moment, travelling through the great dark, untouched by the passage of days on Earth. And so, every twinkle in the sky is a whisper from the past, a fragment of a story still unfolding. The further you look, the further back you peer, until with sufficiently powerful telescopes, You gaze into a universe still wrapped in its infancy, a mere few 100 million years after the first light flickered into being. This temporal reach is not merely a curiosity. It is a profound invitation to see ourselves within a vaster tapestry. The light year, in its duality of distance and time, reveals how deeply entangled we are with the history of the cosmos. Each photon that strikes your eye on a clear, silent night is a traveler, bearing news across gulfs inconceivable. Some come from neighboring stars, their journeys brief on cosmic scales. Others from the remote edges of galaxies whose spirals unwind across eons. Some, perhaps, began their voyage when the earliest forests were greening the earth, or when the first creatures slipped quietly from the sea onto land. The light year stitches us into this narrative, a thread of perception binding the fleeting present to the ancient past. But there is more. The light year is also a mirror held up to our own place in the universe. When astronomers measure the distances to faraway galaxies or map the afterglow of the Big Bang, they are not only charting the cosmos, they are also, in a sense, measuring the reach of human curiosity. Across centuries, the endeavor to quantify such immensity has required not simply mathematics and telescopes, but also poetry, wonder, and a kind of gentle humility. For what are these vast numbers, if not confessions of our own smallness, and at the same time our longing to touch the infinite? It is easy, when confronted with such scales, to feel insignificant. The nearest star beyond the Sun, Proxima Centauri, sits 4.24 light-years away, a distance so immense that even the fastest spacecraft we have built would require tens of thousands of years to reach it. The grand spiral of the Andromeda Galaxy, visible as a faint smudge to the naked eye, is more than 2 million light-years distant. And yet these numbers, daunting as they are not barriers. They are invitations to wonder. They are the measure of our reach, not our limits. The paradox of the light year is that it both humbles and exalts. It reminds us that we are creatures of a tiny blue planet, orbiting an ordinary star in a remote suburb of a spiral galaxy. Our lives are brief, our struggles and triumphs flickering and gone in the blink of cosmic time. And yet, here we are, able to conceive of such distances, to measure them, to dream of crossing them. The light year is a testament to what it means to be human, to wonder, to reach, to seek meaning amid the vastness. We are small, yes, but not insignificant, for the universe is made more luminous by the questions we ask of it. In the poetry of light years, there is a deep echo of our own longings. When we gaze at distant stars, we are also looking back at ourselves, at the hopes and fears, the loves and losses that have shaped our brief passage on this world. The light that has travelled so far to reach us carries with it the memory of cosmic events, the birth and death of stars, the dance of planets, the slow weaving of galaxies. These memories are not ours alone. They belong to the universe, and we, simply by perceiving them, become part of that shared memory. Consider for a moment the light from the Andromeda Galaxy. Every photon that enters your eye has journeyed across 2.5 million years through the emptiness that lies between galaxies. When it began its voyage, the ancestors of modern humans were fashioning simple tools from stone, their lives circumscribed by the rhythms of the earth. In the long interim, empires have risen and fallen, languages have blossomed and faded, and entire civilizations have played out their dramas beneath the same drifting sky. And yet that light endured, unwavering, until it found you, this evening, in this moment, as you gaze upward. There is something quietly miraculous in that, a gentle affirmation that even the briefest life is illuminated by connections that span the ages. The science of light years is not only a matter of telescopes and calculations, it is also a philosophy, a way of thinking about our place in the world. The distances we measure are not merely external, they reflect in some subtle way the distances within ourselves, the span between wonder and understanding, between solitude and connection. To contemplate a light year is to accept the vastness of what we do not know, and to cherish the fragile beauty of what we do. There is woven into the very fabric of cosmic distance a sense of yearning. Our machines can now peer almost to the edge of the observable universe, gathering the faint glow of galaxies whose light has travelled for more than 13 billion years. And yet, for all our reach, we remain bounded by the speed of light, by the impossibility of instant travel or communication across such gulfs. We are, in a sense, always looking back, always receiving messages from the past. The universe we see is never the universe as it is, but as it was. There is a poignant poetry in this, the knowledge that our understanding is always partial, always a step behind the unfolding present. But perhaps this is not a limitation, but a gift. The delay imposed by the light year is a kind of grace, allowing us to glimpse the universe in all its stages, the newborn nebulae, the mature galaxies, the dying embers of ancient stars. We are witnesses to a cosmic pageant that stretches across time, and in bearing witness, we ourselves become part of the story. The light year, in this sense, is not a wall but a window, framing the universe in all its complexity and change. There is another, more subtle implication. The distances marked by light years are not merely cold, indifferent facts. They are the stage upon which our own stories unfold. For every scientist who has peered through a telescope, for every poet who has found solace in the stars, for every child who has traced constellations with a finger against the glass of a winter window, light years are the measure of dreams. They are the spaces into which we project our hopes, our fears, our desire for meaning. In measuring the universe, we are also measuring ourselves. Light, after all, is the great connector. It binds the cosmos together, weaving a network of relationships across space and time. It is through light that we know anything at all about the world beyond our immediate reach, whether it is the fiery heart of a nearby star, the swirling storms of Jupiter, or the faint ghostly glow of galaxies at the edge of sight. Every image, every discovery is a conversation with the universe, conducted at the speed of light, shaped by the patient unfolding of years. And so, in contemplating light years, we are drawn into a deeper reflection on what it means to be human in a cosmos so grand, so indifferent, and yet so intimately known. To measure a light year is to assert our presence, to declare that we are here, capable of understanding and wonder. It is to accept our limits, our finite lives, our bounded perception, and yet to reach beyond them with the quiet hope that the universe, in all its silence, is listening. The poetry of light years lies in this paradox, that we are both distant and connected, fleeting and eternal, lost in the vastness and found in the act of searching. Each discovery, each new measurement, is both an answer and an invitation, beckoning us onward into deeper mysteries. The galaxies spin, the stars are born and die, and through it all the light travels on, bearing witness to a universe in constant motion. We, for a brief moment, catch that light, reflect upon it, and send our own questions back into the night. As the quiet deepens and the night stretches on, one might feel the gentle pull of sleep. Yet even as eyelids grow heavy, the mind is free to wander still, drifting on the currents of imagination, carried along by the thought of light years and what they signify. Somewhere far beyond the edge of sight, new stories are beginning, the birth of a star, the collision of galaxies, the slow, stately dance of planets around distant suns. Their light is already on its way, threading through the darkness, destined to reach eyes not yet open, to kindle wonder in minds not yet born. So it is that the light year, in all its majesty, becomes more than a measure of space or time. It is a testament to our ability to dream, to care, to seek meaning in a universe that is, by turns, both cruel and beautiful. It is a reminder that every life, no matter how brief, is part of something greater, a cosmic tapestry woven from the interplay of light and darkness, matter and mystery. And as you lie in the silence, feeling the world slip away into shadow, perhaps you will remember that you, too, are illuminated by the ancient light of stars. Your very atoms were forged in the hearts of suns that died long before the earth was born. You are, in a sense, a child of light years, shaped by forces vast and deep, yet capable of wonder and reflection. The poetry of light years is not only out there among the galaxies. It is here, within you, breathing quietly in the darkness, waiting to be discovered again with every new dawn. Somewhere in the distance, a star flickers, its light just beginning a journey that will outlast empires and oceans, carrying with it the silent promise of discovery. It will travel for years, for centuries, for millennia, before it finds a receptive mind, an open heart. And when it does, the story will begin anew, woven into the long, unbroken chain of seeing and knowing, of asking and wondering that defines our place in the cosmos. The journey never ends, for light is always on the move, and we, for a little while, are carried along in its wake. As our journey through the vastness of light years gently drifts to a close, may the shimmering distances and cosmic whispers linger softly in your dreams, like a comet tail fading into the hush of space. Rest now in the quiet wonder of the universe, and when you're ready, return for more Dreamtime tales that sparkle just beyond the starlit veil.